children, chapter 12 finished in the previous video. Now we are going to start chapter 13, surface areas and volumes. What is meant by surface areas? Area of a figure. Space inside that figure, that is called area of that figure. Suppose area of this blackboard means here how much space is there, that is called the area of this area. This space, how much we can calculate this, how much space is here in this blackboard, that is called area of that figure. Then surface area means especially about the solid figures, we used to say surface area, solid figures. If a solid figure is there, then it's the outer surface area, that is called surface area of a solid figure, outer surface area. Then here we are going to study surface areas and volumes, but because of this pandemic, then this board already syllabus they have reduced. Because of that, they have reduced the volume portion. So we are going to study only surface areas, the surface area of a solid figures. First here we are going to study surface area of cuboids and cubes. Surface area of cuboid and cube. And what is meant by a cuboid? It is a solid figure. It is a solid figure. Then we can say example. This textbook, if you are catching like that, it is in the form of a cuboid. It has 6 surfaces. In total 6 faces are there. 1 upside, 2, 3, 4, 5, 6 faces are there. It is in the form of a cuboid. That is a rectangular cuboid. It is called a rectangular cuboid. Then here we are going to study the surface area of a cuboid. First we will study the total surface area of a cuboid. Then before that, we have to remember it has length, breadth and height. Height also there. This cuboid has length, breadth and height. This one is the height of the cuboid. How can we draw this cuboid? Cuboid we can draw this way. That is, first you have to draw a rectangle. After that, again one more rectangle we have to draw. So you draw a rectangle here again. One more rectangle. After that, join its vertices. Then we will get a cuboid. Here you have to join. This one you join. All the 4 vertices we will join. Then we will get a cuboid. This one is in the form of a cuboid. Then this one is the length of the cuboid. Length of the cuboid we used to mark it as a small letter L. This one is the breadth of the cuboid, that is B, and it is the height of the cuboid, H. Length, breadth and height. See this textbook. Your textbook is in the form of a cuboid. Then it is the length of the cuboid, breadth of the cuboid. It is the breadth of the cuboid, and this one is the height of the cuboid. It has a height also. Now how many faces are here? See, I told already 6 faces are there. That is, an upside face is there. If you are catching like that, this one is the top face and bottom face, front face, back face. This one is the side face and this one is also a side face. Total how many faces are there? 6 faces are there. 6 faces are there. So surface area of a cuboid means total surface area. All the faces area we have to add together. That is called the total surface area of a cuboid. Now you see, we are going to find out the total surface area of a cuboid. Total surface area, we used to write it as TSA, total surface area. Total surface area is equal to all the faces area we have to add, that much only, all the faces area. So first we have to find out the area of top face. What is the area of top face? This face is in the form of a rectangle. And we know that this one is the length and this one is the breadth. So top face, it is in the form of a rectangle and it is the length and this one is the breadth. So its area will come. What is the formula for finding the area of a rectangle? Area of a rectangle is equal to length into breadth. So if this area, this face area, it will come length into breadth, that is LB we can write, plus now bottom face, this face. What is area of this face? Area of this face is equal to, this one also, it is in the form of a rectangle and this one is the length and it is the breadth. So that also will come length into breadth, that is LB So 2 faces we wrote. Now next one, this front face, find out the area of this front face. Then this face also in the form of a rectangle, that is also in the form of a rectangle, and here you see this one is the length and it is the height. Then this one is the length and this one is the height. So what will come? This area is equal to length into height, that is it will come LH plus then bike face it will come this face, bike face, that is this one also will come same front face, that is L into H, that is LH plus. Now next one, upside face we wrote, downside we wrote, this front face I wrote, bike face also I wrote. Now this face is in the form of a, that also in the form of a rectangle only, then it will come length into, this one is the breadth and this one is the height, so its area it will come B into H, breadth into height, so it will come BH plus. Now this face, last face, that is also breadth into height, that is BH, so it will come BH. Then that is equal to LB plus LB. What is the formula? 2LB plus LH plus LH, 2LH plus BH plus BH. BH plus BH is equal to 2BH. Then now take your 2 common factor. 2 is common here. 2 into LB plus BH plus LH. 2 into LB plus LH plus BH. BH I wrote first, that much only. So we used to write like this: 2 into LB plus BH plus LH. Square unit. If the measurement values, that is the length, breadth and height, it is given in centimeter, then it will come centimeter square, or if it is given in meter, means it will come in meter square. Then that is the total surface area of a cuboid. Total surface area of a cuboid. Now one more is there, lateral surface area of a cuboid. Lateral surface area of a cuboid. Lateral surface area, it is marked as LSA, lateral surface area. Lateral surface area, or it is also called area of 4 walls of a room. That is, we know that our room is in the form of a cuboid only. Then area, lateral surface area means it is the area of 4 walls of a room. 4 walls of that room, it is called lateral surface area. Then this one, just imagine that it is a room. Then 4 walls means what will come? This one is a roof and this one is a floor. This one is the floor and this one is the roof. Now you see 4 walls means these 4 faces it will come. That is called lateral surface area. Now tell me what is the formula then. Then that is this 4 areas, 4 side areas we have to find out. That is called lateral surface area. Then that is or area of 4 walls of a room. 4 walls, area of 4 walls of a room. Now see this face area. What is the area? This one is the length into this one is the height, so it will come LH plus bike face, that also same only LH. Front face and bike face it will come LH plus this side face. This one is breadth and this one is the height, so its area it will come breadth into height, that is BH plus this face also same, that is BH, B into H, that is BH. So that is the lateral surface area. Lateral surface area, remember, top and bottom we will not take, only 4 sides, area of 4 sides, that is called lateral surface area of a cuboid, or it is also called area of the 4 walls of a room. For finding out the area of 4 walls of a room also, we are using this formula. Now add it, LH plus LH, what is answer? 2LH plus BH is equal to 2BH, then that is equal to 2H, we can take out a common factor, 2H into L plus B, 2H into L plus B, or we can write as, in the textbook it is given here, 2 into L plus B into H. Anyway you can write 2H into L plus B or 2 into L plus B into H, both it is same only, In the textbook or last year also you have studied this way, that is why I wrote like that, 2 into L plus B into H, a square unit, 2 into L plus B into H, a square unit. That is the formula for finding the lateral surface area of a cuboid. Lateral surface area 2 into LB plus BH plus LH square unit. Lateral surface area 2 into L plus B into H. Now next one is a cube. Now we have studied a cuboid. Next we are going to study a cube. Now you see, it is a cube. It is in the shape of a cube. That is, difference between cuboid and a cube is that cuboid has a length, breadth and a height, but its all edges are equal. All the edges are equal. If this one is 5 centimeter, then this edge also will be 5 centimeter. This height also will be 5 centimeter. This edge also will be 5 centimeter. All the edges are equal. It is a solid shape and its all edges are equal. That is called a cube. How can we draw a cube? Its all the faces are in the form of a square. So we will draw two squares. Then join its vertices. Then we will get a cube. Join all the vertices, then this one is called a cube. Its all edges are equal. Edges we used to mark it as A. So its length is A, breadth A and height A. All the edges it will be A only. If one edge is A, then all the edges it will be A only. Now how can we find out the total surface area of a cube? Total surface area. Total surface area of a cube is equal to all the, here also 6 faces are there. All the faces area we have to add. Then one first face, upside top face 1, 2, 3, 4, 5 and 6 faces are there. Total 6 faces are there. All the 6 faces area we have to add. That is the total surface area of a cube. Now tell me, what is the area of this face? I told that its edge is A. This one is A, this one A and this one also A. It is in the form of a square. Area of a square is equal to what is formula? A side square. So area of this face is equal to what will come answer? Its edge is A, then area of its face is equal to, it will come a side square, that is A square. So total surface area is equal to A square plus, that is this face only I wrote, then this face, that is A square plus bike face. Bike face, all the faces area it will be same only because its edge is same and all the faces are squares only. So its area will be same only. So bike face also it will come A square plus this face it will come A square plus top face it will come A square plus bottom face also it will come A square. So what is answer? That is equal to A square plus A square 2A square plus A square 3A square plus A square 4A square plus A square 5A square plus A square 6A square square unit. 6A square square unit. That is the formula for finding the total surface area of a cube. Now next one is lateral surface area. Lateral surface area I told in case of a cuboid also, all the four faces, we know that area. Its area is A square plus side face, that is A square, back face, that also it will be A square plus this face it is A square. All the four faces area we have to add. That is called the lateral surface area. Top and bottom we will not take. Now next one, that is equal to A square plus A square 2A square plus 3A square plus A square 4A square square unit. 4A square square unit. So this one is the formula for finding the lateral surface area of a cuboid. Total surface area of a cube is equal to 6A square. Lateral surface area of a cube is equal to 4A square square unit. So these four formulas we are going to use in the first exercise, that is exercise 13.1. Total surface area of a cuboid is equal to 2 into LB plus BH plus LH square unit. Lateral surface area of a cuboid or area of 4 walls of a room is equal to 2 into L plus B into H square unit. Now next one, third formula is total surface area of a cube is equal to 6A square square unit. Lateral surface area of a cube is equal to 4A square square unit. These four formulas you have to study nicely to do the exercise. Okay, let's see the exercise 13.1, question number 1. A plastic box 1.5 meter long, 1.25 meter wide and 65 centimeter deep is to be made. It is opened at the top. Ignoring the thickness of the plastic sheet, determine the area of the sheet required for making the box. How much area of sheet required for making that box, that we have to find out. The cost of sheet for it, if a sheet measuring 1 meter square costs rupees 20. If the cost of 1 meter square sheet is rupees 20, then what will be the total cost of the sheet for making that box? That is the question. Now see, this box is in the form of a cuboid, its length, breadth and height it is given there, and it is given here opened at the top. Top it is open. Okay, first we have to draw a figure. And mark values. Its length is 1.5 meter long, 1.5 meter long, 1.25 meter wide, 1.25 meter wide, and 65 centimeter deep. Its depth or height is equal to 65 centimeter. It is opened at the top and ignoring the thickness of the plastic sheet. That means when we are making this box, this plastic sheet has a thickness. Here a thickness is there. Just ignore that one and find out the area of that sheet. Then determine the area of the sheet required for making the box. How much area of sheet is required for making this box, that we want to find out. Suppose just imagine that it is a cuboid. Then it is then this box opened at the top, it is given there. Then this one also it is opened at the top. So how much area of sheet is required? These are 4 faces we have to keep the sheet, and bottom also. So only this much area we will find out. These are 4 faces and bottom we will find out. Then we will get the area of sheet required for making the box. Now first we have to write the given values here. Whatever values it is given here. Length of cuboid it is given here, or length of box. Length of box we can write it as small letter L. L is equal to 1.5 meter. Breadth of box. Breadth of box B is equal to 1.25 meter, and depth of the box, deep, 65 centimeter deep. Depth means that is the height of the box. Height of box H is equal to, height of box X is equal to what is the value? 65 centimeter. 65 centimeter convert into meter, because next we are going to find out its cost also. Then cost of sheet it is given here, rupees 20 per meter square. That is why we are going to convert this centimeter into meter. This length and breadth it is given in meter. Centimeter also we will convert into meter. How can we convert it into meter? 1 centimeter is equal to how much meter? 100 centimeter is equal to 1 meter. 1 centimeter is equal to 1 divided by 100 meter. 2 centimeter is equal to 2 divided by 100 meter. 3 centimeter is equal to 3 divided by 100 meter. 65 centimeter is equal to 65 divided by 100 meter. That is equal to 65 divided by 100. What is the answer? 0.65 meter. 0.65 meter. That is the height of the cuboid, or height of that box. Okay, now we can find out the area of sheet for making the box. Area of sheet required for making the box is equal to, therefore, area of sheet required for making the box, is equal to, I told that only lateral surface area and area of the bottom. Upside top it is open. Lateral surface area, what is the formula? Lateral surface area of a cuboid is equal to, we have studied the formula, 2 into L plus B into H plus area of the bottom. Area of the bottom is this area it will come, this area, that is length into breadth, LB, length into breadth, that is the area of the bottom, LB. Then that is equal to, now substitute value here, 2 into L plus B. 1.5 meter plus 1.25 meter, 1.5 meter plus 1.25 meter into 1.25 into height H is equal to 0.65 meter, plus length into breadth 1.5 into 1.25, 1.5 into 1.25, then that is equal to 2 into 1.5 plus 1.25, add it, 1.5 plus 1.25, 1.5 plus 1.25, 1.5 we can write as 1.50, 5 plus 0, 5, 5 plus 2, 7, 1 plus 1, 2, that is 2.75, 2.75 into 0.65 plus 1.5 into 1.25. Okay, multiply that. 1.5 into 1.25. 1.5 into 1.25, that is 125 into 15 we will multiply. After that we will put the decimal points. 5 5s are 25 5, remainder 2. 2 5s are 10 plus 2, 12 2, remainder 1. 5 1s are 5 plus 1, 6. 5 1s are 5, 2 1s are 2, 1 1s are 1. 5, 5 plus 2, 7, 6 plus 2, 8, 1. And how many decimal points are there? 1.25 into 1.25 into 1.5 I have multiplied. 125 into 15, 1875 I got. Now here how many decimal points are there? After the decimal point, 1, 2, 3 digits are there. So in the answer also, after the decimal point 3 digits should be there. So it will come answer 1.875. So here it will come 1.875. Now multiply this one, that is equal to 2 into 2.75 into 0.65. 2 into 2.75. 2.75 into 2. 2 5s are 10 0, remainder 1. 7 2s are 14 plus 1, 15 5, remainder 1. 2 2s are 4 plus 1, 5. How many decimal points? 2 decimal points. So it will come 5.50. 2.75 into 2, 5.50 into 0.65. into 65, multiply 65. Then 5 0 0, 5 5s are 25 5, remainder 2, 5 5s are 25 plus 2, 27. 6 0 0, 6 5s are 30 0, remainder 3, 6 5s are 30 plus 3, 33, 0, 5, 7, 3 plus 2, 5, 3. How many decimal points are there? Actually it is 0.65, 5.50 into 0.65. Then total 1, 2, 3, 4 decimal points we have to put here. 1, 2, 3, 4. Then it will come 3.575. 3.5750, that we can write it as 3.575 meter square plus 1.875 meter square. Now add it. That is equal to 3.575 plus 1.875, 1.875, 5 plus 5, 10 0, remainder 1, 7 plus 7, 14 plus 1, 15 5, remainder 1, 8 plus 5, 13 plus 1, 14 4, remainder 1, 3 plus 1, 4 plus 1, 5. So 5.450, we can write it as 5.45 meter square. 5.45 meter square. Plastic sheet is required for making the box. Area of sheet required for making the box. That was the first question. The area of the sheet required for making the box is equal to, what do we got answer? 5.45 meter square. Let's see now question number 2. Second, one more question is there. The cost of sheet for it, if a sheet measuring 1 meter square costs rupees 20. If a sheet measuring 1 meter square costs rupees 20, then what is the total cost of sheet for making this box? That is the question. So here, if it is a 1 meter square sheet, then its cost is rupees 20. We need 5.45 meter square sheet. Then what is the cost of that 5.45 meter square sheet? That is the question. Therefore we can write cost of sheet. Cost of sheet for it is equal to rupees 20 per meter square. It is given there 1 meter square costs rupees 20. That means rupees 20 per meter square into 5.45 meter square. Now here meter square we can cancel. That is equal to rupees 20 into 5.45. Rupees 20 into 5.45. Multiply that. 5.45 into 20. 5.45 into 20. Multiplying here 2 only. 2 5s are 10 0, remainder 1, 2 4s are 8 plus 1 and 9, 2 5s are 10. 2 only I have multiplied, so this 0 we have to put in the answer, so it will come 10,900. And 5.45, 2 decimal points are there, therefore we have to put in the answer also 2 decimal points, that is 109. So what is answer? Rupees 109. 109 rupees is needed to make that box, that is the answer. Okay, now let's see question number 2. The length, breadth and height of a room are 5 meter, 4 meter and 3 meter respectively. Find the cost of whitewashing the walls of the room and the ceiling at the rate of rupees 7.50 per meter square. The length, breadth and height of a room. 5 meter, 4 meter and 3 meter. So here we can write length of the room is equal to length of the room L is equal to 5 meter, breadth of the room B is equal to 4 meter, and the height of the room H is equal to 3 meter. Find the cost of whitewashing the walls of the room and the ceiling at the rate of rupees 7.50 per meter square. For whitewashing 1 meter square, we have to give rupees 7.50. Then what is the total cost of whitewashing? It's the 4 walls and the ceiling. That is the question. So we have to find out area of 4 walls and the ceiling. That is how much meter square area is there, 4 walls and the ceiling. Then after that we have to multiply it by rupees 7.50. Then we will get the total cost of whitewashing the walls of the room and the ceiling. So first we have to find out the area to be whitewashed. Next we will write area to be whitewashed. Area to be whitewashed is equal to we can write area of 4 walls plus area of the ceiling that is equal to area of 4 walls. We have studied the formula. Area of the 4 walls or lateral surface area of a cuboid is equal to, what is the formula? 2 into L plus B into H, 2 into L plus B into H, plus area of the ceiling, that is the top portion of the cuboid. It will come length into breadth, that is LB. Then that is equal to, substitute value here now, 2 into length plus breadth, that is 5 meter plus 4 meter, 5 meter plus 4 meter into height is equal to 3 meter, plus length is equal to 5 meter into breadth is equal to 4 meter. That is equal to 2 into 5 meter plus 4 meter, 5 plus 4, that is 9 meter into 3 meter plus 5 fours are 20 meter into meter square. Then that is equal to 2 threes are 6, 6 nines are 54 meter into meter square plus 20 meter square. 54 plus 20, that is 74 meter square. That is equal to, we can write 74 meter square. So area of the 4 walls and the ceiling is 74 meter square is there. Then here question it is given, the cost of whitewashing is rupees 7.50 per meter square. That means 1 meter square area, for whitewashing 1 meter square area we have to give rupees 7.50. Now 74 meter square area we have to whitewash. It's 4 walls and the ceiling, 74 meter square is there. So 74 meter square area we have to whitewash. Then what is the cost of whitewashing? Therefore we can write cost of whitewashing is equal to rupees 7.50 per meter square, that is the rate, into how much meter square we have to whitewash? 74 meter square area we have to whitewash. That is equal to meter square we can cancel, rupees 7.50 into 74. 7.50 into 74. I am going to multiply 75 into 74. 5 fours are 20, 0, remainder 2. 7 fours are 28 plus 2, 30. 7 fives are 35, 5, remainder 3. 7 sevens are 49 plus 3, that is 52. Then that is equal to 0, 5, 3 plus 2, 5, 5. Then 7.50 into 74. 75 only I have multiplied, so this 10 we have to put it there in the answer. Now 2 decimal points are there, so 2 decimal points should be there in the answer. So what is answer? Rupees 555. If the rate of whitewashing is rupees 7.50 per meter square, then the total cost of whitewashing its 4 walls and the ceiling is rupees 555. That is the answer. Now question number 3. The floor of a rectangular hall has a perimeter 250 meter. If the cost of painting the 4 walls at the rate of rupees 10 per meter square is rupees 15,000, find the height of the hall. We want to find the height of the hall. It is given here the floor of a rectangular hall. Just imagine that this one is a hall, rectangular hall. Rectangular hall means it is in the form of a cuboid only. The floor of a rectangular hall has a perimeter 250 meter. Floor has perimeter 250 meter. This perimeter is 250 meter. That is perimeter of this floor. Perimeter of this floor is equal to 250 meter. Then if the cost of painting the 4 walls at the rate of rupees 10 per meter square is rupees 15,000, find the height of the hall. We want to find the height of this hall. Height x we want to find out. Only perimeter of the floor it is given here. Perimeter of the floor it is given there. Then height of the hall we want to find out. Okay, now see. First we have to write the given values. That is perimeter of floor. Perimeter of floor is equal to what is value 250 meter. Perimeter of floor. Now you see this floor is in the shape of a rectangle. Then perimeter of a rectangle is equal to what is the formula? That is the length of the boundary of that rectangle. Length plus breadth plus breadth. That is 2 into L plus B. It will come 2 into L plus B. L plus L, that is 2L plus B, 2B will come. Then total it will come L plus B plus L plus B, that is 2 into L plus B. That is the perimeter of a rectangle. So perimeter of floor is equal to 250 meter means we can write 2 into L plus B is equal to what is answer? 250 meter. 2 into L plus B is equal to 250 meter. Okay, now next condition. If the cost of painting the 4 walls at the rate of rupees 10 per meter square is 15,000. Cost of painting 4 walls. Cost of painting 4 walls is equal to cost of painting 4 walls. Painting 4 walls is equal to what is answer? 4 walls is equal to rupees 15,000. Cost of painting the floor. How we used to find out that? Rate into rate of whitewashing or rate of painting into area of 4 walls. Area of 4 walls. Area of 4 walls is equal to, we will get rupees 15,000. 15,000. Area cost of painting the 4 walls is equal to area of that 4 walls into rate we will multiply, then we will get the answer. That answer already it is given here, rupees 15,000. That much only. So what is the rate of painting here? Rupees 10 per meter square. That is the rate of whitewashing. So here, sorry, rate of painting. So here we can write rupees 10 per meter square into area of 4 walls. Area of the 4 walls of a room is equal to what is the formula? That is the lateral surface area of a cuboid. That is 2 into L plus B into H. 2 into L plus B into H is equal to rupees 15,000. Now rupees 10 divided by per meter square we will transpose into right side. Then 2 into L plus B into H will remain here. 2 into L plus B value is there. What is there in the question? That is 250 meter. So 2 into L plus B we can write the answer 250 meter into H is equal to rupees 15,000. Rupees 10 per meter square transposing to right side divided by meter square transposing to right side, it will become into meter square. Rupees 10 transposing to right side divided by rupees 10 divided by rupees 10. Now rupees we can cancel, 10 cancel. Now 250 meter also we will transpose into right side, then we will get the height of the cone. Therefore H is equal to 1500 meter square is there into 250 meter transposing to right side divided by 250 meter. H is equal to 10 we can cancel, 1 meter square 1 meter we can cancel, 150 divided by 25, 150 divided by 25 what is answer? 6 into 25 150, 25 into 6, 25 into 6, 6 5s are 30, 0 remainder 3, 2 6 are 12 plus 3 15, 150. So 6 into 25 is equal to 150, 150 divided by 25 that is 6. So H is equal to what is answer? 6, 1 meter we have cancelled, 1 meter will remain there. Therefore height of the hall is equal to, we can write, therefore height of the hall is equal to what is answer? Height of the hall is equal to 6 meter. That is the answer.